Welcome to another math session here in Solve It with Sir Jude. Today we are going to discuss about the 6 trigonometric ratios. So we are now in the 4th quarter and we are going to discuss about trigonometry. So first things first, let us define what is trigonometry. It is a branch of mathematics that deals with the relationship of sides and function of angles of a triangle. So this trigonometry came from the Greek word trigonon, so that is the first word meaning triangle, and metron meaning measurement. So who is the father of trigonometry? If in geometry we have Euclid, in trigonometry we have Hipparchus of Nicaea. So he is a Greek astronomer, a geographer, and at the same time, a mathematician. He is also known for his work about the unit circle, wherein he divided the circle in 360 equal parts. So now let us proceed with trigonometric ratios. So when we talk about trigonometric ratios, these are the ratios of the lengths of the sides of a right triangle with respect to the given acute angle. So the given acute angle here can be represented by capital letter, but it can also be denoted by theta. So this is a Greek letter meaning theta. Okay? So in math, we can use it in denoting angles. So if you can see, we are only focusing on the acute angle of a right triangle. So remember that a right triangle has 3 angles, one right angle and the other 2 are acute angles. So we will be dealing with the 2 acute angles. So let us have a right triangle. So this is our right triangle, TRI. So triangle TRI is right at angle R. So when we are given with acute angle I, so the first thing that we should consider is angle I, we can have the parts of your right triangle. So the side opposite angle I, so that will be side TR or segment TR. Then we have the side adjacent to angle I, so meaning katabi has common vertex, but take note we have here 2 adjacent sides of angle I, so we can have RI and TI. So when we talk about side adjacent to angle I, we are speaking about the non-hypotenuse. So therefore, we will only be including segment RI. Okay? Because we all know that the hypotenuse is the side opposite the 90-degree angle and which is said to be the longest side. So in this case, the hypotenuse is TI. Okay? So kapag sinabing side adjacent to the given angle, hindi yung hypotenuse ang tinutukoy natin because hypotenuse has its own corresponding name. So next, how about if we are going to consider the next acute angle, which is angle T? So mag-iiba naman tayo ng perspective this time. So the side opposite angle T, so that will be segment RI, and then the side adjacent to angle T, again, we are only be considering the non-hypotenuse side for this one, so that will be segment TR. And the last one is the hypotenuse. Remember that the hypotenuse is the side opposite the 90-degree angle. So this is the 90-degree angle opposite it, so that will be our hypotenuse. So in this case, we have segment TI. So next, let us have this triangle ABC. There are other ways in naming the sides of a right triangle. Hindi lang natin ginagamit yung may segment sa taas and then capital letters. We can also denote them or the sides of a right triangle with the use of small cursive letters. So the side opposite angle A, so si angle A ang ating reference dito. So that will be side BC, or it can be denoted as small letter A or baby A. So next, let us have the side opposite angle C. So this is angle C, the side opposite it. So we all know that it is segment AB, but we can also denote it as side C or baby C. And then the last one is the side opposite to angle B. So this is angle B. So opposite it, so that will be segment AC, or it can be denoted as side B or baby B. Okay, so now let us proceed with the 6 trigonometric ratios. So the first of the 6 trigonometric ratios is sine theta. So theta again is the acute angle that we are going to refer to later or will be used as a reference angle. So it can be denoted as sin, S-I-N, theta, which is equal to the ratio of the opposite side over the measure of the hypotenuse. The second one is cosine theta. It can be shortened as cos theta or cos of the given angle. Cosine of the given angle. So it stands for the ratio adjacent side, the length of the adjacent side, over the length of the hypotenuse. And then the last one is tangent theta. Tangent theta can be shortened into tan theta. Okay? It stands for the ratio opposite side over the adjacent side. So these 3 basic trigonometric ratios has its reciprocal. Ano ba yung mga reciprocals niya? So the first one is sine. The reciprocal is cosecant theta. This cosecant theta can be shortened as CSC theta. That stands for, since reciprocal nga siya, babalik na rin lang natin yung position ni numerator at denominator ni sine. So that will be hypotenuse over the opposite side. So next, in cosine, the reciprocal is secant theta. So secant theta can be shortened using sec theta. Okay? So that will just be the reciprocal of cosine. So that will now be hypotenuse over the adjacent side. And then the last one, of course, tangent. The reciprocal is cotangent theta. Cotangent theta can be shortened as cot theta. Cot theta, that stands for the ratio adjacent side over the opposite side. So now, let us have some mnemonic para mas madali nating matandaan. So for the basic trigonometric ratio, the first 3, so we have SO. This is the first one. So SO meaning sine theta is equal to opposite over hypotenuse. So si S dito sa mismong mnemonic, so that will be sine. And then O here stands for opposite side. And then H stands for the hypotenuse. Next, the second one is K. Okay? K stands for cos theta is equal to the adjacent side over the hypotenuse. So C stands for cosine, and A stands for the adjacent side, H stands for the hypotenuse. Then the last one is TOA. So TOA meaning tangent theta is equal to opposite side over adjacent side. So to represent the basic or the 3 basic trigonometric ratios, we have the SO, COT, TOA. So that will be the mnemonic for sine, cosine, and tangent. Si sine, cosine, tangent, makikita mo yan sa iyong scientific calculator. So let us now have the reciprocals. So the reciprocals, the first one is CHO. Okay? CHO meaning or stands for cosecant theta is equal to hypotenuse over the opposite side. So next, for cosine, the reciprocal is secant. So that will now be SHA. CHO, SHA. So SHA meaning secant theta is equal to the hypotenuse over the length of the adjacent side. And then the last one, for the cotangent, we now have tau. Cotangent theta is equal to the adjacent side over the length of the opposite side. So here are the mnemonics. For the first 3 trigonometric ratios, we will be using SO, Ka, TOA. And for the reciprocal ratios, we will be using CHO, SHA, TAU. So let us now have some problems related to the 6 trigonometric ratios. So let us now have the first example. Find the 6 trigonometric ratio of angle A. So let us suppose that this is the triangle wherein the sides are given as 3, 4, and 5. Then, take note that the reference angle that we are going to use is the acute angle A. So let us now have acute angle A. So there is the marking. So now, ang kasunod natin gagawin ay pangalanan yung mga sides with respect to angle A. So we all know that AC, which has the measure of 5 units, is the hypotenuse because it is the side opposite our 90-degree angle. And then, the side opposite angle A, which is BC, that will be our opposite side, which has the measure of 4 units. And then the last part of our right triangle is, of course, AB, which is our adjacent side that measures 3 units. Now, let us proceed with the 6 trigonometric ratios. So yung una muna tayo sa SOHCAHTOA. Let us first have sine. So take note that we change theta here as A because the given reference angle here is A. Okay? So we now have sine of angle A or acute angle A or simply sine A. So remember that sine according to SOHCAHTOA stands for the opposite side over the hypotenuse. So we just need to substitute. So the opposite side is 4 and then the hypotenuse is 5. So therefore sine A will be 4 over 5. So next, let us proceed with cosine. Again, we need to change the theta there, which is A in our example. So remember that cosine A or cosine has its ratio adjacent side over the hypotenuse. So taking this right triangle, so the adjacent side is 3 and the hypotenuse is 5. So therefore, the ratio will be 3 over 5. And then the last one for SOHCAHTOA is tangent. So we now have tangent A since the acute angle is A. So that will be the opposite side over the adjacent side. So we all know that the adjacent side here is 3 and then the opposite side is 4. By a matter of substitution, we now have 4 over 3. So we are through with the first 3 trigonometric ratios. So let us now go or proceed with the reciprocal ratios. So the first one, CHO. So CHO, that will be cosecant A. So that will now be hypotenuse over opposite side. So the hypotenuse is 5 and then the opposite side is 4. So therefore, we now have the ratio 5 over 4. Or you can simply get the reciprocal of 4 over 5. So that will be 5 over 4. And then, let us now go to SHA, meaning secant A is equal to the hypotenuse over the adjacent side. The hypotenuse is 5, the adjacent side is 3, so therefore the ratio will be 5 over 3. And then the last one is the cotangent. So cotangent A is equal to the adjacent side over the length of the opposite side. So substituting the values, we now have the ratio 3 over 4. So hence, we now have the 6 trigonometric ratios of angle A in the given right triangle. So let us now proceed with another example. So example number 2, find the 6 trigonometric ratios of theta. So let us see where is theta. So suppose we have there our right triangle with theta as an acute angle as presented in the figure. So let us now have the measures. So we all know that 13 or the side that has the measure 13 units is our hypotenuse. Next is the side opposite our angle theta or the given angle. So that will be our opposite side. And if you can see, our opposite side is unknown. And the last one is the last side that has the measure 5 units and that will be our adjacent side. If you can see, our given right triangle has one missing leg. So therefore, we need first to use the Pythagorean theorem in order for us to get the measure of the opposite side. So para mamaya makuha na natin siyang mas madali yung 6 trigonometric ratios, since remember, kailangan natin si opposite side sa mga ratios. So to find the length of the opposite side, we need your Pythagorean theorem. So the Pythagorean theorem, that will be the sum of the squares of the legs is equal to the square of the hypotenuse. So if we are going to substitute, so that will now be 5 squared plus x squared is equal to 13 squared. So if you can see, we represented the opposite side as x. Then, if we are going to square the terms, so that will now be 25 plus x squared is equal to 169. Let us now transpose 25 to the other side of the equation, or by just applying your addition property of equality. So thus, we will obtain x squared is equal to 169 minus 25. 169 minus 25, that will be 144. So to get the value of x, we need to extract the square roots of both sides of our equation. And then we will only be using our positive square root of 144 since we are speaking about the length or the measurement of the side of the given right triangle. So therefore, we will be using x is equal to 12 units. So kung mapapansin nyo, kumpleto na yung mga sides ng ating right triangle. So we are now ready to get the 6 trigonometric ratios of the given angle theta. So let us now have sine theta. So again, i-emphasize natin na yung ating reference angle ay kailangang chine-change depende sa given sa statement. So in this one, we have theta. So sabi, find the 6 trigonometric ratio of theta. So therefore, we will be using theta. So that will just be opposite side over the hypotenuse. So by just substituting the value, so we now have 12 over 13. Since we have 12 as the opposite side and then the hypotenuse, we have 13 units. Then, we have cosine theta. So that will be for sine. Ha, so that will be for cosine. So we now have adjacent over hypotenuse. So the length of the adjacent side is 5, while the length of the hypotenuse is 13. So thus we have 5 over 13. So next, tangent theta, so TOA. So we now have opposite side over the adjacent side. So what are their respective lengths? So that will now be 12 over 5. So after getting the first 3 trigonometric ratios, let us now proceed with the reciprocal ratios. So the first one is CHO. So meaning, so that will be cosecant theta is equal to the hypotenuse over opposite. So that will now have the value 13 over 12. So that will be our ratio. So next, let us have our SHA, secant. So that will be hypotenuse over the length of the adjacent side. So by just substituting the values, so that will be 13 over 5. And then the last one is POW, meaning adjacent side over the opposite side. So that will be 5 over 12. So we already completed our 6 trigonometric ratios of the given angle theta in our right triangle. So let us proceed to the third example. So this time, triangle ABC is right at C. If BC is 7 centimeters and AC is 24 centimeters, find the ratios of sine A, cosine A, and tangent B. So we are only asked to find 3 of the ratios. So let us first draw the given triangle. So the right triangle is right at C. So therefore, yung ating right angle, kailangan C ang vertex. So now, take note that BC measures 7 centimeters according to the problem. So here, BC is 7 centimeters. So let us label. And then AC measures 24 centimeters. And then we are asked to find the ratios of sine A, cosine A, and tangent B. Take note that in the right triangle given, missing si hypotenuse. So kailangan muna nating hanapin si hypotenuse given the Pythagorean theorem. So find the length of the hypotenuse. So using the Pythagorean theorem and substituting the values, we have the square of 7 centimeters plus the square of 24 centimeters is equal to C squared. So we represented the length of the hypotenuse as C. Then, upon squaring all the terms, we now have 49 square centimeters plus 576 square centimeters is equal to C squared. Adding, that will now have the result of 625 square centimeters is equal to C squared. Next, to find the value of C, we need to extract the square roots of both sides of the equation. And taking its positive value, we now have the value of C, which is 25 centimeters. So after getting all the sides of the right triangle given, so we are now ready to find sine A, cosine A, and tangent B. So find the ratio of sine A. So that is the first question. Let us now consider that the acute angle is A. So let us now name the sides. So we all know that side AB, which is 25 centimeters, so that is our hypotenuse. Then the side opposite angle A, which is BC, so that will be our opposite side. And of course, AC, which has the measure of 24 centimeters, is our adjacent side. So remember that sine stands for so. Sine theta or sine A, in this case, we have the given angle, which is A, is equal to the opposite side over the hypotenuse. Opposite side is 7, and then the hypotenuse is 25. So therefore, sine A is now equal to 7 over 25. So using the same figure, let us now proceed with cosine A. So again, the given reference angle is A, so we will be using the same figure. So cosine, that will just be adjacent side over the hypotenuse. So So let us now substitute the given measures of the sides. So the adjacent side in our given figure is 24 centimeters, and then the hypotenuse is 25. So hence, we have now the ratio of cosine A, which is 24 over 25. So next, how about tangent B? So in this case, since we are now to consider angle B as our reference angle, so therefore, kailangan nating i-change ang ating figure or yung positioning ng ating mga parts ng right triangle. So since the given acute angle is B, so we all know that the hypotenuse is still AB. So mag-iiba lang yung adjacent at saka yung opposite side natin. So angle B, the opposite side is now AC, and then adjacent side will be BC. Since all the sides are already labeled, we are now to get the ratio of tangent B. So that will just be opposite side over adjacent side. So the opposite side has the measure 24 centimeters over the measure of the adjacent side, which is 7. So we are now through with example number 3. So let us now have the last example, example number 4. So find the remaining trigonometric ratio if sine A is equal to 6 over 7. So let us now have our right triangle here. With the given angle, acute angle is A. So since our reference ratio here is sine A. So ang reference angle is A. So next, sine A is equal to 6 over 7. So take note that sine has the ratio opposite side over the hypotenuse. So therefore, ang ating opposite side has the length 6 units and our hypotenuse has the length 7 units. Now, since we are asked to find the other 5 remaining trigonometric ratios, we are now to find the measure of this leg. So, papaano kukuhain yon or the adjacent side? So, we will be using again the Pythagorean theorem. So, substituting the values, so let us represent the adjacent side, which is B. So, substituting the values, we now have 6 squared plus B squared is equal to 7 squared. Squaring the term, so that will now be 36 plus B squared is equal to 49. Then, we transpose 36 to the other side of the equation, and it will now be B squared is equal to 49 minus 36. Then, 49 minus 36, so that will be 13. And 13 is not a perfect square, so therefore, the value of B is square root of 13 units. So we are now through getting all the measures of the sides of this right triangle. So therefore, ready na rin tayong kuhain yung other remaining trigonometric ratios. So we are done with the sine, the ratio of the sine. So therefore, we will be going with cosine A. So again, ang reference angle is A. So therefore, lahat ng ating trigonometric ratio should use the reference angle A. So cosine, so that will be ka, adjacent side over the hypotenuse. So then, if we are going to substitute the given measures, so the adjacent side is square root of 13 over the hypotenuse, which is 7. So the ratio, square root of 13 over 7. So next, for tangent A, so TOA, so that will be opposite side over the adjacent side, and that will now be equal to, the opposite side is 6, and then the adjacent side is square root of 13. Take note that this fraction has a radical in the denominator. So therefore, we need to rationalize it. How are we going to rationalize? We need to multiply both numerator and denominator by square root of 13. And if we are going to simplify, we will obtain 6 square root of 13 over 13. So next, let us proceed with the reciprocal ratios, CHO. So that will be cosecant A is equal to hypotenuse over the opposite side. By substitution, the hypotenuse is 7 and then the opposite side is 6. So therefore, the ratio for cosecant, that will be 7 over 6. The next one is secant A, siya. So that will be hypotenuse over the adjacent side. The hypotenuse has the measure 7, while the adjacent side we have square root of 13. Again, just like in tangent, we need to rationalize 7 over square root of 13 by multiplying both numerator and denominator by square root of 13. And by simplifying this, we now have 7 square root of 13 over 13. And then the last ratio will be the cotangent or cow. That will now be the adjacent side over the opposite side. So the adjacent side is square root of 13 over the opposite side, which is 6. So we are now done getting the remaining trigonometric ratio if the given ratio of sine A is 6/7. So if you've learned something for today about the 6 trigonometric ratios and other ideas or concepts na kailangan for trigonometry, do not forget to like this video, share this video to others para makatulong tayo sa kanila. And if you are new to our channel, please subscribe to our channel and click the notification bell for more video lessons. So this is Sir Jude. Good day!